We're going to look at a very simple SDK and ModelCenter demonstration. We're going to use a simple design and cost approach with this to try and identify some design considerations for a satellite phased array package for communication with ground assets. And you can see how this is modeled in SDK here as we animate through an overflight downlink opportunity. You can see the phased array shifting power and pointing and doing the things that we've explicitly told that model to perform. And here are some of the setup options. So, defining simple aspects of frequency and power of our transmitter, but most importantly, the phased array antenna itself. So you can see sort of the design approach of changing things like number of elements in X and Y direction to get different design options for the orientation and number of individual elements that make up our total phased array antenna. We can control things like how its beam pointing or targeting should occur throughout our modeled scenario. We can change some basic properties or parameters like modulation or filtering and some other things that just add additional realism or constraints that we may know exist on this particular design. Of course, these design options have complexity and cost that we also have to consider. And in this simple example, we have some costs. These are all absolutely notional, but these are used to determine a rudimentary total cost of a design configuration for our antenna and our transmitter. So you can see some basic simple assumptions like cost per antenna element, and of course, as the complexity or number of those elements in our design grows, this may require us to have to accommodate more complex or higher powered power subsystems, and those have different costs. So you can just see some of those assumptions and some of those design considerations captured here in that Excel sheet. Now here in ModelCenter, we can see how we're going to begin linking these two modeling simulation artifacts together. So ModelCenter has inbuilt a lot of these plugins. They're very easy to use. We can just take them and drag and drop them onto our design workspace. So I've already pulled in an SDK plugin as well as an Excel plugin. And if I open the properties of the SDK plugin, for example, you'll see the SDK analyzer interface that basically mimics my SDK scenario. It shows me all of the same objects that exist in my SDK scenario and gives me access to parameters and properties and outputs of things that I have calculated on the SDK side. So you can see a few of those here. It's very easy to just drag those over as design input variables and outputs that I might be interested in leveraging or using. And you can see those show up here in the component tree, the ones that I've identified. So they're all linked together in the sense that I can pull SDK parameters and Excel parameters and identify those and make those sort of show up in my design space. And then to make them talk to each other, it's this link editor approach, which is very simple. We just drag and drop inputs and outputs from one plugin to the next so that they can share information. So just as a quick example, let's say I change the number of elements in my design. I can execute my Excel sheet. It shows me that it has determined a certain power and a system cost that has updated in my SDK scenario, and then I ask it to calculate what my expected max carrier power at receiver input metric would be for that design. And I can keep walking through and updating these and asking for those output metrics. But the real strength here is once these are designed, wired up, and talking to each other, I can start to use some of ModelCenter's inbuilt trade study tools. You can see a couple of these along the top bar. For this example, I've sort of pre-populated a design of experiments approach where I'm pulling in design variables, in this case, X and Y elements in my phased array. I want to look at responses like my max performance as well as the total system cost. These are things that are coming from two different elements in my wired up design inside of ModelCenter. So I can give upper lower boundaries and maybe a number of iterations and come up with an entire trade space. So these are all design points or configurations that I'm going to ask to be automatically computed and calculate and characterize. So I can run this and you'll see, I'll sort of speed this up a little bit just for the sake of time, but you'll see each one of these considerations start to calculate. And I can start to look at them statistically in some unique ways. So you can see sort of a response surface here, a contour plot that is populating as I go through and calculate all 100 of these design points. So I can see things like number of elements in either direction, and I can look at objectives and goals and color this in unique ways that may give me more information from a design perspective. There's other ones to look at, like this is a scatter matrix, might identify some edge cases or certain conditions where I get unexpected performance or minimized cost. I can look at how variables independently may influence some of my output results in certain unique ways. So hopefully you can see how something like this, even though it's a simple example, this can be used as complexity of systems grow and more design considerations need to be made. These automated studies are very useful.